Hi, I'm Sid Dhuri. I head the analytics practice for claims at Hiscox, and I'm quite excited to present at Rework on how we help understand the pain on the claim for our customers, and we are employing human in the loop AI. So let's see what we do. So what you see over here is a customer who's just bought an iPhone and is really excited about his purchase. He's very happy. He's having a positive interaction with the Apple staff over there, and is very excited to probably he's going to go on social media and write about how excited he was to use the iPhone. Now we work in the insurance industry. And I can't imagine any customer going and going, "Oh, I'm so excited! I bought this insurance policy." In fact, after taking out an insurance policy, many customers interact with their carrier only when they've experienced a loss and they are in a distress and they're trying to make a claim. So the interaction level is not quite the same. And quite often, these customers, when they do contact a carrier, are at a very vulnerable stage, and it's very important for carriers to understand their pain and help them and sort out their issues in this time of need. And how are customers interacting with insurers in these days? So what we've seen is that there's an increasing trend where insurers, in addition to using the traditional channels of calling up an insurer, they're also using social media and various other online media. This survey by ITDS, which is a consulting firm, found that 20 insurers, out of them, most of the insurers were offering social media as media or as a channel for interaction with customers. And they found that Twitter was one of the leading ways where people were expecting a response in a very short time. So users are very interactive. They are talking a lot on social media, and there's a lot of good insights over there. And for insurance, it's not always that there's only painful comments. For example, I've worked in the pharmaceutical industry before, and very similar industry. You buy both insurance and also pharmaceutical drugs to allay some sort of pain. So there also they do try to understand the needs of the customers through social media and various other media. What you see over here is a picture of a pill for Parkinson's disease. So this is equipped by GSK. And one of the insights that they found from customer feedback was that because Parkinson's patients, they find it difficult to lift a pill if it's flat on the table. So they've designed this pill, which has just pie sides and has a pointed fulcrum in the middle, so it can never lie flat. And similarly, for insurance, you can understand how to design the product experience or service experience for customers. And so there's not just a lot of painful or negativity in the comments, but also there's some very useful insights that insurers can use. Now, what is the challenge with going and looking at various emerging media and social media to look at for customer comments is that the scale of data can be really large. And in our experience, so we've been looking at loss narratives, claims notes, customer complaints, NPS data, Trustpilot and FIFO reviews, and even social media such as Twitter. And it's a lot of text. It's a lot of free text. It's not very easy to classify the documents, to understand what things people are talking about. So we are trying to identify ways in which machine learning can help humans to identify the key things or key themes that people are talking about. So we employed some text mining techniques. Now, while we've done things like sentiment analysis, named entity recognition, and others, one of the key techniques that we've employed to help users understand the pain in the claim is LDA for using topic modeling. So what is topic modeling? Is given that if you treat all the comments as a bag of words, then we want to understand what are the various latent topics that these comments would be talking about. So, for example, claims or which are talking about words like lawnmower, landscaping, garden. So they might be talking about professional indemnity. Similarly, claims that are talking about slip, fall, and trip, they might be talking about bodily injury. And then this helps us to classify the documents and understand the cause of loss and various other attributes of a claim. So how do we do that is by using an algorithm called a latent judicial allocation. This was introduced by Andrew Ng and David Embley in 2003. So to explain you how this algorithm works, just imagine that my corpus has 3 topics: astronomy and sports and food, and all the 3 topics are organized at the points of a corner of a triangle. Now, if documents that have words like football, free kick, goal, they would go in the sports corner of the distribution. Documents that talk about solar, Orion, Mercury, they would be placed in astronomy. Similarly, documents that talk about pasta, sauce, soup would be placed in the food corner. Now, a document can also be in the middle, so it can be talking about 2 topics like cricket, bat, or catch, like catch of the day, for example, would be between food and sports. Similarly, document that talks about Mars orbit could be talking about astronomy, or it could be talking about food because Mars chocolates or orbit. And similarly, a document which is like talking about a galaxy, stars, it could be between sports, astronomy, or food. LA Galaxy, which is the football club, Galaxy chocolate bars, or even Galaxy, the Milky Way that we all live in. So this is the blueprint for the latent judicial allocation. So what you see over there on the right, on the left-hand side, we have the list of documents that are fed into this machine, if you imagine. And the gray ball that you see, the W, so that's the only observed element, which is the observed word. And based on these words, we want to understand what are the various topics that this word would belong to, and similarly, what are the various topics that would be part of a document. So to put it mathematically, we are trying to calculate the conditional probability of given a specific word. We see one word at a time. What is the probability of this topic having occurred? And then given the topic, I think what is the probability that this document has the distribution of topics? If you look at the question or equation over here, so we are trying to estimate the parameters or approximate the distribution using Dirichlet distributions for topics over terms, and then distribution of documents over topics. Now I can see that looks a bit scary, a bit complex, and can be quite difficult to understand. But let me tell you that probably you implemented a latent judicial allocation algorithm without even knowing. So how do we implement an algorithm to in real life, for example? So just imagine that you've moved into a new house, you packed everything into a truck, you moved out, and then you unloaded everything in the new house. Now, if you imagine each item to be a word and the topics to be something like a bedroom, a kitchen, a bathroom, and you want to identify the correct location of every item or every word in this case. So I don't know where exactly these things need to go through, but I know that where each item is with respect to each other. So, for example, if I know that if I look at the shoe, I know I can put it maybe next to the shoe. Similarly, I'd look at the next hanger. I would put it next to the other hanger that we have. The trousers, I will put it next to a shirt. The dining table and chair, I can put it next to the cutlery. Then I see a desk, I can put it under the computer, and I can put my chair next to the computer and the desk. I have a couch, I can put the couch in front of the television, and then the remaining t-shirt, I can put it next to my clothes. So here we have, so without knowing where exactly everything needs to go through, but just looking at one item at a time and imagining that everything else is in its correct place, we've tried to give some sort of order. It might not be the correct place to that where these things eventually end up, but we can now give some sort of an order to the chaos that we had. So this is a very good example of how LDA works. It employs something called as Gibbs sampling. This is what we just do to estimate those parameters for Dirichlet distribution. Now, There are some challenges with natural languages. So a lot of the natural language processing algorithms, they are trained on uh, beautiful language like Jane Austen, Agatha Christie, and Shakespeare. But then we apply them in the real world, and the real world language can be a bit ambiguous and a bit messy. So, for example, natural language has many ambiguities, such as lexical ambiguity, homonymy, polysemy, one word with many meanings. Then there's syntactic ambiguity as well. So, for example, the word pen, there's so many interpretations of the word pen. The writing instrument, confinement for chicken, something for where you can babies play, correctional institution, even a female swan. Similarly, syntactic ambiguity is when Sherlock Holmes saw the man using binoculars. Was Sherlock using the binoculars, or the man was using the binoculars? And there's also semantic ambiguity. And to add to that, because we are using phones nowadays, I think we quite often do spelling mistakes, and we tend to use colloquial words that might not be part of the actual dictionary. Excuse me. So, given these challenges, we need to get the context from the users and help the machines also in terms of understanding the context. So that's where we introduced human in the loop AI. So how this works is that humans have an understanding of the domain knowledge. So in an insurance domain, a pharmaceutical domain, so you have the understanding of the corpus, what some words mean, what some words have a over there. But machines don't have access to this, and we need to encode this information in a way that the machines can interpret and use it in their machine learning model. So one way to do this is through a taxonomy. So this is a sample taxonomy for the disease multiple sclerosis, where the high-level topics are something like drugs, side effects, conditions, treatments. And within side effects, there's subtopics such as vision problems, bowel, bladder issues, fatigue problems, and other things. And within walking, there's even subtopics. It's a hierarchical taxonomy. Taxonomy for insurance looks something like that. This is like causes of causes, something like bodily injury, cyber, equipment damage, and then within equipment damage, we have multiple sub causes. So we can use this as a way, as an input of the domain knowledge that we can fed into the machine for natural language processing. Now, in addition to the human input, we start with the basic taxonomy. The machine can help the user to build taxonomy. So, for example, while going through the actual corpus, users can select the word, and then the machine will now help you to identify words that are similar with spelling mistakes or something. For example, over here, the user is selecting the word boots. And now boots means pharmaceutical drugs, so he's adding to the topic drugs. When he's adding it to the drugs, the machine in the background is going through the entire corpus, trying to identify similar words. So it's found words similar like bouts and books. And so how does it work is that it's looking, stemming the word, and identifying words which are similar either in terms of phonetic similarity or minimum estate distances, or words that are synonymous. And then it makes those suggestions, and then users can then select whether they want to add this to the taxonomy. So once again, a user creates a basic taxonomy, the machine helps to with suggestions using various NLP techniques. The user can also understand the various context in which words are used. So, for example, you can see in this corpus, the word needle was used in multiple contexts. So one was the injections that patients had to take, and at the same time, needles is being used as the sensation of pain, the pins that patients have experienced. So users can also understand if a word that they're adding to taxonomy, what are the various contexts in which they are used. Also, understanding the various relationship between words. So how is one word related to different other words within the corpus? So for that, we look at pairwise correlations. This is very similar to the Pearson's correlation that we look at between two variables, but over here we're looking at various words within the corpus. So, for example, over here that you can see that legs and steroids are highly correlated because one of the reasons is that the people who are facing fatigue have been taking steroids. So, similarly, you can identify words that have high correlation and what relationship they are. And then when you start connecting this network of words, you can have topics that you can, or other concepts that are clustered together. And that also helps the users to understand the context in which words are used, the various words that people are using, and how words are related and concepts are related to each other. Now, we are trying to fit all this into the latent ratio allocation that we just saw some time back. And how does it help to improve the algorithm? So right now, what you're going to see is the plain vanilla application of LD algorithm to detect topics. So if you see that it has found about, because I asked it to find 5 topics, it's found topics with the first one talking about head, partner, the second one talking about DLA forms and benefits, and then the other one talking about blood levels and high. So what we saw is that the number of topics that came out, and there was not a lot of cohesion and coherence that we could understand, easily interpret the various topics that were being churned out by the LD algorithm. Now, what we do is same algorithm with the same corpus, we input it with a very basic taxonomy that we've created over there. And with that, has the input changed or anything? So we see that one topic is talking about legs, walking, needles, lesions, fatigue, nerves, and the topic. So this topic is talking about people experiencing pain while walking. And this is talking about diseases, high levels of blood sugar, diabetes patients who are also having multiple sclerosis. Similarly, people who are taking steroids, and eyes, and talking about a fish. Then this one is talking about diet, where people are relying on omega-3 fatty acids to as part of the diet. And the last topic, which is talking about insurance support benefits, and the insurance around the management of the disease. So what we found was that the topics were a bit more coherent and a bit more user understandable after we were able to help the LD algorithm with the user input. Okay, so we've done all this. So we've done the classification of the comments. We've given the machines the input, and the machines have given us some richer topics. So what can we do with it? Now, once we've given structure to our unstructured data, it can be used in for data visualizations or basic analysis, and it just makes a lot of analysis possible. So right here that we can see that this is a sunburst chart, which is showing that out of my entire discussion, I think 41% of the discussion was about side effects, and within side effects, patients are talking about bowel issues, 2.91. Within that, incontinence, 0.832. So this is a good immediate understanding of a corpus. If you have a taxonomy ready, you can key in you can add the corpus. Taxonomy gets applied to your entire corpus, and within a few seconds, you are able to understand what the discussion is about. And this can be used for understanding the various topics that are being discussed. What is the share of a discussion, or in claims case, what is the book of business? Or these can also be used in customer service training, the words that people are using, and hence can be used in various other initiatives as well. So just to reiterate how we are using human in the loop training, human in the loop AI over here. So the user, if the human first starts represent domain knowledge in the form that the machines can understand, in the form of a taxonomy, then AI augments the human inputs with suggestions using, again, applying NLP techniques. Then based on this improved and augmented taxonomy, the machine is able to model topics and relationships in the corpus guided by the domain knowledge. And then the users are able to explore context and relationships. Again, the machine helps to identify that by building networks and connections and correlations between various concepts. So machines can take some human help. We know that AI is really advancing, but machines can get confused to, is this a chihuahua or is this a muffin? Or is this a kitten, or is this a caramel ice cream? So and I'll leave you with this last quote by Alan Turing. So we can only see a short distance ahead, but we can see plenty there that needs to be done. Machines might be really powerful and they might have a lot of compute power, but definitely as humans, we cannot be as compute intensive as machines, but we can do a lot more to help the machines provide better outcomes. So that's it from me. Thank you.